Okay, so you're scrolling as one does, and you keep coming across these videos of robots, and you're wondering to yourself, how can I make a robot myself? Well, the first thing I want to tell you is it's not as hard as you may think it is. It's hard, don't get me wrong, but it's not as hard as you think it is. And the first step to getting into robotics is seeing something that is common between all robots, and that's something called a microcontroller. Hi, my name is Callum, and in today's video, I'm going to be talking about what a microcontroller is, how you use it, and what can you use it for. This is a microcontroller. Specifically, it's an ESP32. But for now, we're not going to worry about that. Let's focus first on this front end, and then we'll go to the back. Let's focus on the main kind of parts of it that I think are important for a beginner to understand. Okay, this is a very simple diagram of a microcontroller, specifically the one I use, an ESP32. Keep in mind that not all microcontrollers look like this, but they all serve the same purpose. So what is that purpose? I like to think of a microcontroller as a bridge. It's the bridge between software and hardware. So a lot of times when you're seeing these robots, there is hundreds and hundreds of lines of code that make something move, if you will. So here, on this side is where you would plug in from your computer, pretend that's a USB, and this is where you would upload all your software, all your code into your microcontroller, and it's all stored in this processor right here. We'll switch colors. That's our processor right there. Okay? So now our processor will take the signals and pretty much the instructions from your software, and it's going to interpret those, and it'll send an output to whatever it may be. Maybe it's like a servo motor or something like that, right? So it'll just pretty much just make this spin if that's what your code tells it to do. So right there is where we would plug in, and this is the processor. So now begs the question, how do the signals that get interpreted by the processor actually go to the hardware? Well, that's when we flip to the back and we see all these pins. Okay, here is a very simple diagram of the back of the microcontroller. And you'll notice all these pins. Now, most of them are referred to as GPIOs. That stands for General Purpose Input or Output. So when you plug any component, whether it would be a servo motor or an ultrasonic sensor or maybe like an LCD or something, it's either inputting information to your microcontroller or it's receiving information or directions, if you will. So a servo motor would be receiving instructions because it's taking whatever the code is telling it to do and it's turning however much the code tells it to. So these would be all GPIOs. And the reason why I said most of them are GPIOs is because not all of them are, as you could assume. There are certain pins that are designated to voltage. So typically this may be something around here would be voltage, and with any circuit, there has to be a power supply as well as a endpoint, in this case scenario, a ground. So many of the pins are reserved for using it for your components. However, there are pins that are used up for other purposes. In essence, that's all a microcontroller is. It's a bridge between software and hardware. It takes a set of directions from your code, your software, interprets it, and then spits out physical electrical signals to the hardware to make it actually work. I hope this video kind of took away a little bit of anybody's fear to get started, and just to show you that you can understand it. It's not impossible to understand, and you can start. So, but if anybody has any questions, I urge you guys to leave them in the comments or do your own research and start making.